darkest of nights, far from the lights of cars and cities, something special appears in the sky. A cloudy white stripe of light stretches across the heavens. Ancient peoples thought it looked like a stream of milk spilled across the sky, and so it is called the Milky Way. The Milky Way that we see in the sky is part of a galaxy, or a huge collection of stars, gas, dust, and other material. Galaxies are held together by gravity, much the same way that our solar system is held together by the sun's gravity. The Milky Way is our galaxy, where our solar system is located, but the solar system is just a tiny piece of the galaxy. The Milky Way is enormous, at least 100,000 light years across. A light year is how far light can travel in 1 year, nearly 6 trillion miles. In addition, the Milky Way has at least 200 billion stars and probably at least 100 billion planets in it. Although it is massive, the Milky Way is not alone in the sky. It's part of a collection of other galaxies called the Local Group, made of about 50 galaxies nearby to ours. The Local Group is estimated to be at least 10 million light-years across. Outside of the Local Group, scientists estimate that at least 170 billion galaxies exist in the part of the universe that can be seen from Earth, and there is no way to know how many more there are beyond that. Galaxies come in many different shapes and sizes. They may have only a few million stars in them, or over 1 trillion. They may be elliptical, spiral, or irregular in shape. The Milky Way, like most known galaxies, is a spiral galaxy. Although no one knows what the Milky Way actually looks like because it is impossible to see all of it from the inside, careful observations of it as well as other galaxies has given scientists a good idea of its shape. There are four main parts in the Milky Way. In the center is the bulge, or galactic center. This is a round bump in the center of the galaxy, about 10,000 light-years across, densely packed with stars and other material. Scientists believe that at the very center of the Milky Way is a giant black hole. The galactic center is the brightest part of the galaxy. Next is the disk, a flattened region surrounding the bulge in the center. The disk is about 100,000 light-years across. It is filled with young stars, gas, and dust, concentrated in the spiral arms. The spiral arms are part of the disk and make the galaxy look a little like a pinwheel. Our solar system is located in one of the Milky Way's spiral arms, where star systems are spread much farther apart than in the crowded galactic center. The last part of the Milky Way is the halo. The halo is a mostly spherical layer of old stars and star clusters that surrounds the main disk of the galaxy. The halo is very empty compared to the rest of the galaxy, with everything in it spread very far apart. Ancient Greek philosophers thousands of years ago first suggested that the Milky Way might be made of faraway stars that were close together, but there was no way to prove this until the 1600s, when the astronomer Galileo Galilei observed the Milky Way with his telescope and discovered that it was, in fact, made of many, many faint stars. If you can find some
ನಮಸ್ಕಾರ, ಎಲ್ಲರಿಗೂ ಶುಭ ಸಂಜೆ, ಗುಡ್ ಈವ್ನಿಂಗ್. ನವರಾತ್ರಿಯ ಶುಭಾಶಯಗಳು ಮತ್ತು ಅಡ್ವಾನ್ಸ್ ಆಗಿ ಎಲ್ಲರಿಗೂ ವಿಜಯದಶಮಿ ಶುಭಾಶಯಗಳು. ಈ ಹಬ್ಬದ ಸಮಯದಲ್ಲಿ let us see some bright crackers in the sky. Today we are going to have this session in English for a change. That has been demand from some of our audience, and this time we're going to have it in English. Today we have two well-known people from education sector. One is Mr. R.S. Burudi, who's currently BO at Gadag district, Irhatti Taluk, and he has been enthusiast in science and mathematics, and he has done a lot of initiatives to improve performance of students in SSLC and various grades. And he has been lending helping hand for Tare Zameen Par, and thanks to him, and he's going to do a opening remark today. And we have one more gentleman, Satyakumar Sharma, who is a renowned astronomer, astrophotographer. He has done his graduation from United Kingdom, Salford, University of Salford, Manchester, and he has around 20 years of experience in this area. And I had an opportunity to work with him for 4.5 years when he was working with Government of Karnataka Science and Technology, Karnataka Science and Technology Promotion Society. And I think the kind of in-depth knowledge that he has about astronomy is amazing. I think we are all lucky to have him here on this platform today. And I think, astronomy is one subject where not many rural kids get an opportunity to, do a deep dive into this subject. Especially, astronomy needs telescopes, planetarium kind of tools, which we lack in rural area. I think, this is the best opportunity where we learn some of these concepts and take it to our kids, and followed by, we'll also take our planetarium to these kids. And please feel free, we are there to, be there wherever you call, along with our team. I call upon Mr. R.S. Burudi sir. Sir, ತಾವು ಓಪನಿಂಗ್ ರಿಮಾರ್ಕ್ ಮಾಡ್ಬೇಕಂತ ಕೇಳ್ಕೊಳ್ತೇನೆ. ಬುರುಡಿ ಸರ್.
Thank you, sir. Thank you.
ಹೇಳಿ ಸರ್.
Good evening, everybody. ನನಗೆ ಮಧ್ಯಾಹ್ನ ಹೊತ್ತು ವೀರೇಶ್ ಫೋನ್ ಮಾಡಿ, ಸರ್ ನಮ್ಮ ಪ್ರಯತ್ನದಲ್ಲಿ ನೀವು ಸತತವಾಗಿ ಭಾಗಿಯಾಗಿದ್ದೀರಿ, ನಮ್ಮ ಪ್ರಯತ್ನದ ಬಗ್ಗೆ ಒಂದೆರಡು ವಿಚಾರಗಳನ್ನ ಹಂಚ್ಕೊಳ್ಬೇಕಂತ ಅಂದ್ಕೊಂಡಾಗ ಖಂಡಿತವಾಗ್ಲೂ ಯಾಕಾಗಬಾರ್ದು ಅಂತೇಳಿ ನಾನು ಒಪ್ಕೊಂಡು ಶ್ರೀ ದಿನೇಶ್ ಬಾಡ್ಗಂಡಿ ಅವರು ತಾರೆ ಜಮೀನ್ ಪರ್ ಅಂತಕ್ಕಂಥ ಸಂಚಾರಿ ತಾರಾಲಯವನ್ನು ಪ್ರಾರಂಭ ಮಾಡಿ ರಾಜ್ಯದ ಮೂಲೆ ಮೂಲೆಗಳಲ್ಲಿ ಗ್ರಾಮೀಣ ಭಾಗದ ಮಕ್ಕಳಿಗೆ ಒಂದು ಸೌರವ್ಯೂಹದ ಬಗ್ಗೆ, ಜೊತೆಗೆ ನಕ್ಷತ್ರಗಳ ಬಗ್ಗೆ ಕುತೂಹಲವನ್ನು ಮೂಡಿಸ್ತಕ್ಕಂಥ, ಜ್ಞಾನವನ್ನು ಕೊಡ್ತಕ್ಕಂಥ ಒಂದು ಅದ್ಭುತವಾದಂತ ಪ್ರಯತ್ನವನ್ನು ಮಾಡ್ತಾ ಇದ್ರು. ಆ ಪ್ರಯತ್ನದ ಭಾಗವಾಗಿ ಅವರು ನಮ್ಮ ಗದಗ ಜಿಲ್ಲೆಗೆ ಬಂದಾಗ ಗದಗ ಜಿಲ್ಲಾಡಳಿತ ಭವನದ ಹಾಲ್ನಲ್ಲಿ ಆ ಕಾರ್ಯಕ್ರಮ ನಡೆದಿತ್ತು. ಆ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಭಾಗಿಯಾದಾಗ ನಾನು ಮಕ್ಕಳಿಗೆ ಒಂದು ಮಾತನ್ನು ಹೇಳಿದ್ದೆ, ನಿಮ್ಗೆಲ್ರಿಗೂ ಕನಸನ್ನು ಹುಟ್ಟು ಹಾಕ್ತಕ್ಕಂಥ ಒಂದು ಪ್ರಯತ್ನವನ್ನ ದಿನೇಶ್ ಅವರು ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಆದ್ದರಿಂದ ಈ ಕಾರ್ಯಕ್ರಮ ಕನಸು ಬಿತ್ತುವ ಕಾರ್ಯಕ್ರಮ ಅಂತೇಳಿ ನಾನು ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ. ಆ ಹಿನ್ನೆಲೆಯಲ್ಲಿ ರಾಜ್ಯಾದ್ಯಂತ 8 ಲಕ್ಷ ಮಕ್ಕಳಿಗೆ ಈಗಾಗಲೇ ದಿನೇಶ್ ರವರು ತಮ್ಮ ತಂಡವನ್ನು ಕಟ್ಟಿಕೊಂಡು ಸಂಚಾರಿ ತಾರಾಲಯದೊಂದಿಗೆ ಶಾಲೆಗಳಿಗೆ ಹೋಗಿ ಗ್ರಾಮೀಣ ಭಾಗದ ಮಕ್ಕಳಲ್ಲಿ ಯಾರಿಗೆ ಇಂಥ ಸೌಲಭ್ಯಗಳನ್ನ ಹೊಂದಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇರಲಿಲ್ಲವೋ, ಯಾವ ಶಾಲೆಗಳಲ್ಲಿ ಇಂಥ ಸೌಲಭ್ಯಗಳು ಇರಲಿಲ್ಲವೋ ಅಲ್ಲೆಲ್ಲ ಹೋಗಿ ತಮ್ಮ ತಂಡದೊಂದಿಗೆ ಮಕ್ಕಳಿಗೆ ಕುತೂಹಲ ತನಿಸ್ತಕ್ಕಂಥ ಒಂದು ಪ್ರಯತ್ನವನ್ನು ಮಾಡಿದ್ದಾರೆ. ಆ ಹಿನ್ನೆಲೆಯಲ್ಲಿ ಅವರಿಗೆ ನಾನು ಅಭಿನಂದನೆ ಸಲ್ಲಿಸ್ತೇನೆ. ಜೊತೆಗೆ ಇತ್ತೀಚೆಗೆ ಅವರು 13 ಕಾರ್ಯಕ್ರಮ ಬಹಳ ಅದ್ಭುತವಾಗಿ ಮೂಡಿ ಬಂತು. ಅದರಲ್ಲಿ ಕೆಲವನ್ನು ನಾನು ಇಲ್ಲಿ ಉಲ್ಲೇಖಿಸೋದಾದರೆ, ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ದಿ ಪ್ಲಾನೆಟರಿ ಮೋಷನ್ ಯೂಸಿಂಗ್ ಎ ಕ್ಲಾಕ್. ಡಾಕ್ಟರ್ BS ಶೈಲಜಾ ಮೇಡಮ್ ರವರು ಅದ್ಭುತವಾಗಿ ತಮ್ಮ ಇಳಿ ವಯಸ್ಸಿನಲ್ಲಿಯೂ ಕೂಡ ಬಹಳಷ್ಟು ಶಿಕ್ಷಕರ ಮತ್ತು ಈ ಸೈನ್ಸ್ ಬಗ್ಗೆ ಕುತೂಹಲ ಇರತಕ್ಕಂಥವ್ರು ಅದರಲ್ಲಿ ಈ ಕ್ಲಾಕ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿ ಯಾವ ರೀತಿ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬಹುದು, ತಿಳಿಸ್ಕೊಡ್ಬೋದು ಅನ್ನೋದನ್ನ ಬಹಳ ಅದ್ಭುತವಾಗಿ ತಿಳಿಸ್ಕೊಟ್ರು. ಜೊತೆಗೆ ಡಾಕ್ಟರ್ TB ಅಳ್ಳೋಳಿ ಅವರು ರೋಲ್ ಆಫ್ ಟ್ರೀಸ್ ಇನ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಎನ್ವಿರಾನ್ಮೆಂಟ್ ಅಂತಕ್ಕಂಥ ಟಾಪಿಕ್ ನ ವೆಬಿನಾರ್ ನಲ್ಲಿ ಬಹಳ ಅದ್ಭುತವಾಗಿ ವೃಕ್ಷವನ್ನ ಯಾಕೆ ರಕ್ಷಣೆ ಮಾಡಬೇಕು, ಕೃಷಿಗೆ ಹೇಗೆ ಉಪಯೋಗ ಆಗ್ತಿದೆ, ಅಥವಾ ಈ ಮಣ್ಣಿನ ಸವಕಳಿ ಹೇಗೆ ಆಗುತ್ತೆ ಅದನ್ನ ಹೇಗೆ ತಡೆಗಟ್ಟಬಹುದು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಬಹಳ ಅದ್ಭುತವಾಗಿ ತಿಳಿಸ್ಕೊಟ್ರು. ಜೊತೆಗೆ ಸಾಂದರ್ಭಿಕವಾಗಿ ಒಂದು ವೇಳೆ ನಾವು ವೃಕ್ಷವನ್ನ ರಕ್ಷಣೆ ಮಾಡದೇ ಇದ್ರೆ, ಮಣ್ಣಿನ ಸವಕಳಿಯನ್ನ ತಪ್ಪಿಸದೇ ಇದ್ರೆ ಏನೆಲ್ಲ ಅನಾಹುತ ಆಗ್ಬೋದು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಒಂದು ವಚನಕಾರರ ವಚನವನ್ನ ಅವರು ಅಲ್ಲಿ ಕೋಟ್ ಮಾಡಿದ್ರು. ಅದೇನಂದ್ರ ಒಲೆವತ್ತಿ ಉರಿದರೆ ನಿಲ್ಲಬಹುದು, ದರೆ ಹೊತ್ತಿ ಉರಿದರೆ ನಿಲ್ಲಬಹುದು ಅಂತ ಬಹಳ ಸೂಕ್ತವಾದಂತಹ ಕೋಟ್ ಅನ್ನು ಬಳಸಿ ಇವತ್ತು ಸೈನ್ಸ್ ನಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಕ್ಷೇತ್ರದಲ್ಲಿ ನಾವು ಅಭಿವೃದ್ಧಿಯನ್ನು ಹೊಂದಿದ್ರು ಕೂಡ ವೃಕ್ಷವನ್ನ ಅಂದ್ರೆ ಕಾಡನ್ನ ರಕ್ಷಣೆ ಮಾಡದೇ ಇದ್ರೆ, ಮಣ್ಣಿನ ಸವಕಳಿಯನ್ನ ತಪ್ಪಿಸದಿದ್ರೆ ಏನೆಲ್ಲ ಅನಾಹುತ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಬಹಳ ಅದ್ಭುತವಾಗಿ ತಿಳಿಸ್ಕೊಟ್ರು. ಇನ್ನೊಂದು ವೆಬಿನಾರ್ ವಿಜ್ಞಾನದ ರಸಪಾಕ, ಅದು ರಸಪಾಠ ಅಂತಕ್ಕಂಥ ಅದ್ಭುತವಾದಂತ ಅನುಭವಿಗಳಾದಂತ ನಾಗೇಶ್ ಹೆಗಡೆ ಅವರು, ಅವ್ರ ಜ್ಞಾನವನ್ನ ನಾವು ಇನ್ನಷ್ಟು ಪಡ್ಕೋಬೇಕು. ಈಗಿನವರು ಒಂದ್ ವೇಳೆ ಪಡ್ಕೊಳ್ಳದೆ ಹೋದ್ರೆ ಒಂದು ಜನರೇಷನ್ ಗ್ಯಾಪ್ ಆಗ್ತಕ್ಕಂಥ ಸಂದರ್ಭ ಇದೆ. ಆ ಹಿನ್ನೆಲೆಯಲ್ಲಿ ನಾಗೇಶ್ ಹೆಗಡೆ ಅವರು ಎಂತ ಅದ್ಭುತವಾದಂತ ವಿಚಾರಗಳನ್ನ ಹಂಚ್ಕೊಂಡ್ರೆ ಅಂದ್ರೆ, ಮನುಷ್ಯ ತಾನೇ ಬುದ್ಧಿವಂತ, ತಾನೇ ಶ್ರೇಷ್ಠ ಅಂತಕ್ಕಂಥ ಒಂದು ಹಮ್ಮಿಕೆಯಲ್ಲಿ ಎಲ್ಲೋ ಒಂದು ಕಡೆ ಅನೇಕ ಆಪತ್ತುಗಳನ್ನ ತಂದುಕೊಳ್ತಿದ್ದಾನೆ ಅಂತಕ್ಕಂಥದ್ದನ್ನ ಅವ್ರು ವಿವರಿಸಿದ್ರು. ಆವಾಗ ಅವರು ಒಂದು ಉದಾಹರಣೆಯನ್ನು ಕೊಟ್ಟರು. ಮನುಷ್ಯನ ವಿಕಾಸದ ಉದಾಹರಣೆಯನ್ನ ಕುತ್ತಿಗೆಯಿಂದ ಒಂದು ಕೈಯನ್ನು ಚಾಚಿ ಒಂದು ಚಿತ್ರವನ್ನ ತೋರಿಸಿ ಆ ಪ್ರಗತಿ ಹೇಗೆ ಆಯ್ತು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ, ಮೊದಲಿಗೆ ಏಕಕೋಶ ಜೀವಿಗಳು ಬಂದು, ನಂತರ ಫಸ್ಟ್ ಫ್ಲವರ್ ಬಂತು, ಆಮೇಲೆ ಡೈನೋಸಾರ್ ಬಂತು, ಆಮೇಲೆ ಮ್ಯಾಮಲ್ಸ್ ಬಂದು, ನಂತರ ನ್ಯಾಂಡ್ರಲ್ಸ್ ಬಂದು, ಮನುಷ್ಯ ಬಂದ. ಅದಾದ ಜೊತೆಗೆ ಕೃಷಿ ಜೊತೆಗೆ ಕಲ್ಲಿದ್ದಲು ಬಳಸಿದ, ಪೆಟ್ರೋಲ್ ಬಳಸಿದ, ಆಂಟಿಬಯೋಟಿಕ್ಸ್ ಬಂದು, ವಿಮಾನ ಬಂದು, ಯೂರಿಯಾ ಬಂತು, ಅಣುಬಾಂಬ್ ಬಂತು, ರಾಕೆಟ್ ಬಂತು, ಬಾಹ್ಯಾಕಾಶ ಬಂತು, ಕಂಪ್ಯೂಟರ್ ಬಂತು, ಕೊನೆಗೆ ಕೊರೋನಾ ಬಂತು ಅಂತೇಳಿ ಬಹಳ ಮಾರ್ಮಿಕವಾಗಿ ತಮ್ಮ ವಿಶ್ಲೇಷಣೆಯನ್ನು ಮಾಡಿದ್ರು. ಅಂದ್ರೆ ಇವತ್ತು ಜ್ಞಾನದ ಜೊತೆಯಲ್ಲೇನೆ ಮನುಷ್ಯ ಯಾವ ರೀತಿ ವಿಜ್ಞಾನವನ್ನ ಅಜ್ಞಾನದಿಂದ ಬಳಸ್ತಾ ಇದ್ದಾನೆ ಅಂತಕ್ಕಂಥದ್ದನ್ನ ಬಹಳ ಅದ್ಭುತವಾಗಿ ಅವರು ವಿಶ್ಲೇಷಣೆ ಮಾಡಿದ್ರು. ಅಂದ್ರೆ ಜಗತ್ತಿನಾದ್ಯಂತ ವಿಜ್ಞಾನದ ಜೊತೆಗೆ ಮನುಷ್ಯ ಅಪಾಯವನ್ನ ತಂದೊಡ್ತಕ್ಕಂಥ ಎಷ್ಟೆಷ್ಟು ಅಣುಬಾಂಬುಗಳನ್ನು ಹೊಂದಿದ್ದಾನೆ ಅಂತಕ್ಕಂಥದ್ದನ್ನ ಬಹಳ ಚೆನ್ನಾಗಿ ವಿವರಿಸಿದ್ರು. ಇನ್ನೊಂದು ವೆಬಿನಾರ್ ನಲ್ಲಿ 21st ಸೆಂಚುರಿ ನಾಲೆಜ್ ಸೆಂಚುರಿ ಅಂತಕ್ಕಂಥ ವೆಬಿನಾರ್ ಅನ್ನು ಬಹಳ ಅದ್ಭುತವಾಗಿ ಈ ತಾರೆ ಜೆಮಿನಿಫರ್ ತಂಡದವರು ಆಯೋಜಿಸಿದ್ರು. ಅದರಲ್ಲಿ ನಮ್ಮ ಅಪರ ಆಯುಕ್ತರಾದಂತ ಮೇಜರ್ ಸಿದ್ಲಿಂಗನವರು ಕೂಡ ಭಾಗವಹಿಸಿ ತಮ್ಮ ವಿಚಾರಗಳನ್ನ ಹಂಚಿಕೊಂಡ್ರು. ಮೊನ್ನೆ ನಡೆದಂತ ಇನ್ನೊಂದು ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಅಗ್ರಿಕಲ್ಚರ್ ಮತ್ತು ಹಾರ್ಟಿಕಲ್ಚರ್ ಸೈನ್ಸ್ ಬಗ್ಗೆ ಡಾಕ್ಟರ್ ಅಶೋಕ್ ಆಲೂರ್ ಅವರು ಹೊಸತನದಿಂದ ನಾವು ಹೇಗೆ ಕೃಷಿಯನ್ನ ಮಾಡಬೇಕು, ತಂತ್ರಜ್ಞಾನವನ್ನ ಯಾವ ಸಂದರ್ಭದಲ್ಲಿ ಬಳಸಬಹುದು, ಜೊತೆಗೆ ಯಾವ ರೀತಿ ಹೊಸ ರೀತಿಯ ಉಪಕರಣಗಳನ್ನ ನಾವು ಬಳಸಬೇಕು, ಮಾರುಕಟ್ಟೆಯನ್ನ ಹೇಗೆ ನಾವು ಪ್ರೊವೈಡ್ ಮಾಡ್ಕೋಬಹುದು ಅನ್ನೋ ಸೃಷ್ಟಿ ಮಾಡಿಕೊಳ್ಳುವುದ್ರ ಬಗ್ಗೆ ಬಹಳ ಅದ್ಭುತವಾದಂತ ಇನ್ನೊಂದು ವೆಬಿನಾರ್ ಮೂಡಿ ಬಂತು. ಅವರು ಸಾಂದರ್ಭಿಕವಾಗಿ ತಾರೆ ಜೆಮಿನಿಫರ್ ತಂಡದವರು ವಿಜ್ಞಾನ ತಂತ್ರಜ್ಞಾನ ಇಲಾಖೆ ಸಹಯೋಗದೊಂದಿಗೆ ಶಿಕ್ಷಕರಿಗೆ ಹೊಸತನದಿಂದ ಕೂಡಿದಂತ ಹೊಸ ವಿಷಯಗಳನ್ನು ಹೇಗೆ ಕೊಡಬೇಕು, ಅದನ್ನು ಬಳಸಿಕೊಂಡು ಶಿಕ್ಷಕರ ಹೊಸ ಕೌಶಲ್ಯ ಮತ್ತು ಸೃಜನಾತ್ಮಕತೆಯೊಂದಿಗೆ ಹೀಗೆ ಪಾಠ ಬೋಧನೆಯನ್ನ ಮಾಡಬೇಕು, ಮಕ್ಕಳು ಹೊಸತನವನ್ನು ಹೇಗೆ ಅಳವಡಿಸಿಕೊಳ್ಬೇಕು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಹೊಸ ಟಾಪಿಕ್ಗಳನ್ನ ಬಳಸ್ತಾ ಬಂದ್ರು. ಅದ್ರ ಮುಂದುವರೆದ ಭಾಗ ಇನ್ನೊಂದಂದ್ರೆ ನಕ್ಷತ್ರ ವೀಕ್ಷಣೆಯ 108 ಪ್ರಶ್ನೆಗಳು ಅಂತಕ್ಕಂಥ ಬಸವಪ್ರಭು ಅವರ ವೆಬಿನಾರ್ ಬಹಳ ಅದ್ಭುತವಾಗಿತ್ತು. ಜನರ ಕುತೂಹಲಗಳ ಬಗ್ಗೆ, ಸಂಶಯಗಳು, ಪ್ರಶ್ನೆಗಳ ಬಗ್ಗೆ ಉತ್ತರವನ್ನು ಕೊಡ್ತಕ್ಕಂಥ ಒಂದು ಪ್ರಯತ್ನ ಅಂತ ನಾವು ಅನ್ಬೋದು. ಅದ್ರ ಜೊತೆಯಲ್ಲಿ 2 ನೇರವಾಗಿ ಶಿಕ್ಷಕರಿಗೆ ಅನುಕೂಲ ಆಗ್ತಕ್ಕಂಥ 2 ಟಾಪಿಕ್ಗಳು ಬಂದ್ವು. ಒಂದು ಸೌರವ್ಯೂಹದ ಗೋಚರ ಮತ್ತು ವಾಸ್ತವ ವರ್ಸಸ್ ವಾಸ್ತವ ಅಂತ ರಾಮಸ್ವಾಮಿ ಅವರು ಕೊಟ್ಟಂತ ಪ್ರಾಯೋಗಿಕ ಚಟುವಟಿಕೆಗಳು, ವಿಜ್ಞಾನದ ಚಟುವಟಿಕೆಗಳನ್ನ ಹೇಗೆ ಸಾಮಾನ್ಯರಿಗೆ ತಿಳಿಸ್ಬೇಕು. ಬಹಳಷ್ಟು ಜನರು ಏನ್ ತಿಳ್ಕೊಂತಾರಂದ್ರೆ ವಿಜ್ಞಾನ ಅಂದ್ರೆ ಅದು ವಿಜ್ಞಾನಿಗಳಿಗೆ ಸಂಬಂಧಪಟ್ಟಿದ್ದು, ಶಿಕ್ಷಕರಿಗೆ ಸಂಬಂಧಪಟ್ಟಿದ್ದು ಅಂತಕ್ಕಂಥ ಭಾವನೆ ಇದೆ. ಅದು ಅಲ್ಲ, ವಿಜ್ಞಾನ ಸಾಮಾನ್ಯರಿಗೂ ಕೂಡ ಅನುಕೂಲ ಆಗ್ತಕ್ಕಂಥದ್ದು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ರಾಮಸ್ವಾಮಿ ಅವರು ಬಹಳ ಒಳ್ಳೆ ವೆಬಿನಾರ್ ನಲ್ಲಿ ಉಪನ್ಯಾಸವನ್ನು ನೀಡಿದ್ರು. ಜೊತೆಯಲ್ಲಿ ಲರ್ನ್ ಸೈನ್ಸ್ ಬೈ ಡೂಯಿಂಗ್ ಹ್ಯಾಂಡ್ಸ್ ಆನ್ ಆಕ್ಟಿವಿಟಿ ಫಾರ್ ಟೀಚರ್ಸ್ ಅಂತಕ್ಕಂಥ ಟಾಪಿಕ್ ಮೇಲೆ ಬಾಬಾನಗರ್ ಅವರು ಕೂಡ ಸಣ್ಣ ಸಣ್ಣ ಚಟುವಟಿಕೆಗಳನ್ನ ಕಡಿಮೆ ಖರ್ಚಿನ ಮತ್ತು ಲೋ ಕಾಸ್ಟ್ ಮಟೀರಿಯಲ್ಸ್ ಅನ್ನು ಬಳಸಿ ಹೇಗೆ ನಾವು ಸೌರವದ ಕಾನ್ಸೆಪ್ಟ್ಗಳನ್ನ, ಸೈನ್ಸ್ನ ಕಾನ್ಸೆಪ್ಟ್ಗಳನ್ನ ತಿಳಿಸ್ಕೊಡ್ಬೋದು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಬಹಳ ಚೆನ್ನಾಗಿ ತಿಳಿಸ್ಕೊಟ್ರು. ಅದರ ಇನ್ನೊಂದು ವೆಬಿನಾರ್ ಜ್ಞಾನ ವಿಜ್ಞಾನ, ಹೀಗೆ ಹಲವಾರು ಟಾಪಿಕ್ಗಳ ನಂತರ ಇವತ್ತು ನಾವು ವಂಡರ್ಸ್ ಆಫ್ ಮಿಲ್ಕಿ ವೇ ಅಂತಕ್ಕಂಥ ಟಾಪಿಕ್ಗೆ ಬಂದು ನಿಂತಿದ್ದೇವೆ. ಒಟ್ಟಾರೆ ನಾನು ಈ ಸಂದರ್ಭದಲ್ಲಿ ಹೇಳಿಕ್ಕೆ ಬಯಸೋದಂತಂದ್ರೆ, ಕೋವಿಡ್ ಸಂದರ್ಭದಲ್ಲಿ ಶಾಲೆ ಮತ್ತು ಮಗುವಿನ ನಡುವೆ ಗ್ಯಾಪ್ ಆಗಬಾರ್ದಂತೇಳಿ ಶಿಕ್ಷಣ ಇಲಾಖೆಯವರು ಒಂದು ಕಡೆ ಚಿಂತನೆ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ತಾರೆ ಜಮೀನು ಪರ ತಂಡದವರು ಕೂಡ ಶಿಕ್ಷಕರಿಗೆ ಕಲಿತಕ್ಕಂಥ ಅವಕಾಶಗಳು ತಪ್ಪಬಾರದು, ಆ ಮೂಲಕ ಮಕ್ಕಳಿಗೂ ಕೂಡ ಕಲಿಕಾ ವಾತಾವರಣದಿಂದ ವಿಮುಖರಾಗಂತ ಸಂದರ್ಭ ಒದಗಿ ಬರಬಾರದಂತ ಹಿನ್ನೆಲೆಯಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಅಂಶಗಳನ್ನ ಗುರುತಿಸಿ ಆ ಮೂಲಕ ಶಿಕ್ಷಕರಿಗೊಂದು ಒಳ್ಳೆಯ ಜ್ಞಾನವನ್ನು ಕೊಡ್ತಕ್ಕಂಥ ಪ್ರಯತ್ನವನ್ನ ಪ್ರತಿ ವಾರ ವೆಬಿನಾರ್ ಮೂಲಕ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಅದರಲ್ಲಿ ಅವರು ಹೆಚ್ಚು ಆದ್ಯತೆಯನ್ನು ಕೊಟ್ಟಿದ್ದು ಕಲಿಕಾ ಕೌಶಲ್ಯಗಳು, ವಿಜ್ಞಾನವನ್ನ ಸರಳವಾಗಿ ಹೇಗೆ ಮಕ್ಕಳಿಗೆ ತಿಳಿಸಿ ಹೇಳ್ಬೋದು, ಜೊತೆಗೆ ವೃತ್ತಿಪರತೆಯನ್ನ ಹೇಗೆ ನಾವು ಇನ್ನಷ್ಟು ಬೆಳೆಸ್ಕೊಳ್ಬಹುದು, ಹೊಸ ಹೊಸ ಅಂಶಗಳನ್ನು ತಿಳಿಸ್ಕೊಳ್ಬಹುದು, ಈಗಿರ್ತಕ್ಕಂಥ ಕೋವಿಡ್ ಸಮಯವನ್ನ ಏನು ನಮ್ಗೆ ಅವಕಾಶಕ್ಕಿದೆ ಶಾಲೆಗಳು ಇಲ್ಲದಂತ ಸಂದರ್ಭದಲ್ಲಿ ಅದನ್ನ ಹೇಗೆ ಸರಿಯಾಗಿ ಬಳಸಿಕೊಳ್ಬಹುದು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಇವತ್ತು ದಿನೇಶ್ ಬಾಡ್ಗಂಡಿ ಅವರು ರಾಜ್ಯದ ಮೂಲೆ ಮೂಲೆಗಳಿಂದ ಅನೇಕ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳನ್ನ, ಅನುಭವಸ್ಥರನ್ನು ಕರೆಸಿ ಶಿಕ್ಷಕರಿಗೆ, ಮಕ್ಕಳಿಗೆ ಒಳ್ಳೆಯ ವಿಷಯವನ್ನ ತಲುಪಿಸ್ತಕ್ಕಂಥ ಪ್ರಯತ್ನ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಅವ್ರು ನೋಡಿ, ಒಂದು ಕಡೆ ಜೂಮ್ ಮೀಟಿಂಗ್ ಮಾಡ್ತಾರೆ, ಇನ್ನೊಂದು ಕಡೆ ಎಲ್ಲಾ ಶಿಕ್ಷಕರು ಮತ್ತು ಮಕ್ಕಳಿಗೆ ಅಥವಾ ಆಸಕ್ತರಿಗೆ ಭಾಗವಹಿಸ್ಲಿಕ್ಕೆ ತೊಂದರೆ ಆಗಬಾರ್ದು ಅಂತೇಳಿ ಯೂಟ್ಯೂಬ್ ನಲ್ಲಿ ಕೂಡ ಲೈವ್ ಹೋಗ್ತಾ ಇದ್ದಾರೆ. ಒಂದು ಇಂಗ್ಲಿಷ್ ನಲ್ಲಿ ವೆಬಿನಾರ್ ಕ್ಲಾಸ್ ಬಂದ್ರೆ ಮತ್ತೊಂದು ಕನ್ನಡದಲ್ಲಿ ಬರ್ತಾ ಇದೆ. ಹೀಗೆ ಹಲವಾರು ಪ್ರಯತ್ನಗಳ ಮೂಲಕ ಶಿಕ್ಷಕರಿಗೆ ಕಾಳಜಿಯನ್ನು ವ್ಯಕ್ತಪಡಿಸ್ಬೇಕಂತೇಳಿ ಗ್ರಾಮೀಣ ಭಾಗದಲ್ಲಿ ವಿಜ್ಞಾನದ ಕುತೂಹಲವನ್ನು ತನಿಸ್ತಕ್ಕಂಥ ಪ್ರಯತ್ನವನ್ನು ಅವರು ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ನಾನು ವಿಶೇಷವಾಗಿ BUI ಕೆಲಸ ಮಾಡುವಾಗ ವೀರೇಶ್ ಅವರು ತಮ್ಮ ತಂಡವನ್ನು ಕಟ್ಟಿಕೊಂಡು ಸಂಚಾರಿ ತಾರಾಲಯವನ್ನು ತಗೊಂಡು ಗ್ರಾಮೀಣ ಭಾಗದಲ್ಲಿ ಸರ್ ನಾವು ಇವತ್ತು ಈ ಶಾಲೆಯಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದೇವೆ, ಈ ಶಾಲೆಯಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದೇವೆ ಅಂತೇಳಿ ನಮ್ಮನ್ನು ಕೂಡ ಆಹ್ವಾನಿಸ್ತಿದ್ದೆ. ನಾನು ಕುತೂಹಲದಿಂದ ಭಾಗವಹಿಸಿ ಅಲ್ಲಿ ಒಂದು ಪ್ರಯತ್ನದಲ್ಲಿ ಭಾಗಿಯಾಗಿದ್ದೇನೆ. ಹತ್ತಿರದಿಂದ ಅವರ ಪ್ರಯತ್ನವನ್ನು ನೋಡಿದ್ದೇನೆ. ಜೊತೆಗೆ ನಮ್ಮ ತಾಲೂಕಿನಲ್ಲಿ ಒಂದು ದಿನದ ವಿಜ್ಞಾನ ವಸ್ತು ಪ್ರದರ್ಶನ ಅಂತೇಳಿ ಮಾಡಿದಾಗ ಆ ಕಾರ್ಯಕ್ರಮದ ಜೊತೆಯಲ್ಲಿನೇ ಈ ಕಾರ್ಯಕ್ರಮವನ್ನು ಸೇರಿಸಿ ನಾವು ಮಕ್ಕಳಿಗೆ ವಿಜ್ಞಾನದ ಜ್ಞಾನವನ್ನು ಕೊಡ್ತಕ್ಕಂಥ ಪ್ರಯತ್ನ ಮಾಡಿದ್ವಿ. ಒಟ್ಟಾರೆ ಈ ಜೊತೆಗೆ ನನ್ನ ನೂರಿನ ಮಕ್ಕಳಿಗೂ ಕೂಡ ಇದರ ಜ್ಞಾನವನ್ನ ಒತ್ತಾಯ ಮಾಡಿ ಕರ್ಕೊಂಡೋಗಿ ಮುಗಿಸಿದ್ದೇನೆ. ಒಟ್ಟಾರೆ ರಾಜ್ಯದ ಜನತೆಗೆ, ಮಕ್ಕಳಿಗೆ, ಶಿಕ್ಷಕರಿಗೆ ದಿನೇಶ್ ಅವರು ಮಾಡ್ತಕ್ಕಂಥ ಪ್ರಯತ್ನ ಬಹಳಷ್ಟು ಅನುಕೂಲ ಆಗಿದೆ. ಈ ರೀತಿಯ ಪ್ರಯತ್ನಗಳು ಮುಂದುವರಿಲಿ ಅಂತಕ್ಕಂಥ ಮಾತನ್ನ ಈ ಸಂದರ್ಭದಲ್ಲಿ ಹೇಳ್ತಾ, ನಾವು ಮಾಡ್ತಕ್ಕಂಥ ಯಾವ ಪ್ರಯತ್ನವೂ ಕೂಡ ಏನದು ವಿಫಲ ಆಗುದಿಲ್ಲ ಅಂತ. ಖಂಡಿತ ಎಲ್ಲಾ ಪ್ರಯತ್ನಗಳು ತನ್ನದೇ ಆದಂತ ಫಲಿತಾಂಶವನ್ನ, ಪರಿಣಾಮವನ್ನು ಕೊಡ್ತಾವಂತ. ಅದಕ್ಕೆ ದಿನೇಶ್ ಅವರು ಅವರ ತಂಡ ಮಾಡ್ತಕ್ಕಂಥ ಪ್ರಯತ್ನದಿಂದ ಬಹಳಷ್ಟು ಜನರಿಗೆ ಖಂಡಿತ ಉಪಯೋಗ ಆಗ್ತೈತಿ. ಅವರ ಪ್ರಯತ್ನಗಳು ಮುಂದುವರಲಿ, ಎಲ್ರಿಗೂ ಒಳ್ಳೇದಾಗ್ಲಿ ಅಂತ ಹರಸಿ ನನ್ನ ಮಾತನ್ನು.
ಧನ್ಯವಾದ ಸರ್. ತುಂಬಾ ಚೆನ್ನಾಗಿ ಸಮರೈಸ್ ಮಾಡಿದ್ರಿ ನಮ್ಮೆಲ್ಲಾ ಕಾರ್ಯಕ್ರಮಗಳನ್ನ ಇಲ್ಲಿವರೆಗೆ. ಧನ್ಯವಾದ ಸರ್. ಇನ್ಫ್ಯಾಕ್ಟ್ there is a lot of learning that we have taken from BO ಸರ್. ಬುರ್ಡಿ ಸರ್, ವೀರೇಶ್ ನಿಮ್ಮಿಂದ ಸಾಕಷ್ಟು ಕಲಿತು ನಮ್ಮಲ್ಲಿ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಥ್ಯಾಂಕ್ ಯು ಸರ್. So let us now start this program. We have wonderful gentleman Satyakumar Sharma. We fondly we call him as Satya. He is popularly known as Satya. And a couple of points about Satya. He has started this initiative on his own after coming out from Government of Karnataka, a company called Universal Immersive Media and Education. And he ನೀವು ಎಲ್ಲೇ ಕರೆದ್ರು, ಇನ್ಫ್ಯಾಕ್ಟ್ ಒಬ್ರು ಪಾಸ್ಕಲ್ ಅಂತ ಒಬ್ರು ಟೀಚರ್ ಈಗ ತಾನೇ ಮೆಸೇಜ್ ಹಾಕಿದ್ರು, ನಿಮ್ಮ ಮಕ್ಕಳಿಗೆ ಎಲ್ಲೇ ಪ್ರೋಗ್ರಾಮ್ ಮಾಡ್ಬೇಕಾದ್ರೂ ಸತ್ಯ ಅವ್ರು ಬರ್ತಾರೆ, ತಮ್ಮ ಟೆಲಿಸ್ಕೋಪ್ ಅನ್ನು ತಗೊಂಡ್ ಬರ್ತಾರೆ. ಮಕ್ಕಳಿಗೆ ನೈಟ್ ಸ್ಕೈ ವಾಚಿಂಗ್ ಪ್ರೋಗ್ರಾಮ್ ಮಾಡಿ ಎಲ್ಲ ಟ್ರೈನಿಂಗ್ ಕೊಟ್ಟು ತುಂಬಾ ಚೆನ್ನಾಗಿರ್ತದೆ. ಐ ಥಿಂಕ್ ಯು ಶುಡ್ ಯುಟಿಲೈಸ್ ಹೀಸ್ knowledge. And I have had a great experience working with him. And a few rules here. If you have any questions, please raise your hands. We will unmute you at the end of the program, and you can ask your question. And we will come across a few words which are like you might get confused. Like some of these words would be like million. Million andre 10 laksha. ಗೊತ್ತಿರುತ್ತೆ ನಿಮಗೆ, ಆದ್ರೂ ಲೈಕ್ ಮಿಲಿಯನ್ ಅಂದ್ರೆ 10 ಲಕ್ಷ, ಬಿಲಿಯನ್ ಅಂದ್ರೆ 10,000 ಲಕ್ಷ, ಬಿಲಿಯನ್ ಅಂದ್ರೆ. ಆಮೇಲೆ ಲೈಟ್ ಇಯರ್ ಅಂದ್ರೆ 9 into 4.6 into 10⁻12. It's a huge number. Light traveled in a span of 1 year. So I think these are the terminologies I'm sure Satya will be explaining each and everything. And he's a great storyteller. Voice modulation alla madbittu, I think he has learned a great art of storytelling. Over to you, Satya. I'll not take much of your time. Go ahead. You are mute.
Yes.
You are on.
Yeah, now I've unmuted myself. Very good evening to all the participants. And I'm really excited to speak at the Tare Zameen Par webinars, because we have a lot of participants, and it's really nice that, people are spending so much time on a festival evening, even if it is for an hour or hour and a half. So without much ado, I will talk about the topic of the day. The topic of the day is getting to know our Milky Way, the galaxy that we call home. So I will begin my presentation. Right. Oops, that's on the last slide. Right. Okay. Full screen. Okay. Via Lactea means the pathway of the milk. It has a very nice story to it. Basically, the milk is from the goddess Hera. She's a Greek goddess and the wife of Zeus. And her milk, where it spills because of an incident, that it's called the Milky Way. And that is basically Via Lactea. So this is our galaxy, a sneak peek into the galaxy we call home. Once again, I am Satyakumar Sharma. I'm the founder of Universal Immersive Media and Education. I could probably tell you about that at the very end of the lecture. Now, we all know about the Big Bang. The Big Bang happened about very close to 14 billion years ago. That is a really, really long time. This is a very famous graphic that is available everywhere, and it shows the timeline of the expansion of our universe, which happened after the Big Bang. When the Big Bang happened itself, the very first stars of the universe took about 400 million years to come. Mr. Dinesh just mentioned 1 million means 10 lakhs. So 400 into 10 lakhs. So many years to actually going to, I mean, that much time it has taken, basically. Sorry, I just got disturbed by a mobile phone. All right. Now, until this time, it was called the Dark Ages, because there was nothing as such. And then started the development of the galaxies, the planets, and everything. The formation of the structures of our universe, it took a long period of time. What happened was, there were, after the Big Bang, slightly, denser regions of gas, of mainly hydrogen and other things. So what happened? They came across because of gravity. When what happens is, if there is a huge cloud of, let's say, hydrogen gas, and there's a lot of pressure there, a lot of gravity happening, it attracts nearby matter, and it grows denser and denser and denser. This is exactly how a star forms, you see. Basically, if a star has to form, it's the hydrogen fusion reaction. There's a lot of hydrogen, pressurized, compacted, and a lot of gravity and a lot of heat that generates, and then there is a ignition point where the star takes birth. Okay, so this is exactly what is happening here. And because the denser regions attracted more gaseous matter from nearby, and it grows even more denser. forming gas clouds, and then forming stars, as I just mentioned, and other astronomical structures which are visible today. Like, the galaxies formed, then the generations of the stars also change, because the stars have a life and death, and the cycle keeps repeating. And many stars then tend to have the disks of dust around them, and these the dust again coalesce together again because of gravity, pressure, and other things, and they form planets. So that's the way the universe works. So, all right. So what happened is, 1 second, sorry. What many people thought previously to be, um, 1 second, sorry. Yeah. So the gas and dust which people saw, I mean, there were a lot of observations that happened even before Dr. Edwin Hubble took over the reins of, identifying galaxies and other things. These galaxies and other things were earlier called as nebulae. Okay. Hubble proved that many objects which were, these dust and gas clouds, which were called as nebulae, they were actually galaxies which were beyond our own Milky Way. I'm yet to come to our own Milky Way and what it contains, but this is like a, what do you say, a foreword or a preface that I'm giving, a build up, if I must say that way, right? So outside the universe first, and then we come back home. Hubble provided evidence. What happens is, the more distance you go away from Earth, the faster these galaxies seem to be going away from us. That property known as Hubble's law. Okay, even though it was earlier proposed, as I've shown by George Lemaitre, it is now very popularly known as Hubble's law. And of course, the Hubble Space Telescope that we have all come to see for the past nearly 30 years plus, that is named in his honor, of course. All right, there are two images here. The one on the left is, of course, the Hubble Space Telescope. The one on the right is something called the extreme deep field taken by the Hubble Space Telescope. Now, this space telescope, which is controlled from Earth, it has nearly 2.3 meter mirror in it. I won't talk about the types of telescopes here, rather concentrate on what it actually does. Now, the image on the right, every single spot in that image, every single, even that star-like dot you see in that image is actually a galaxy. Okay, the most extreme image of any galaxy region captured by the Hubble Space Telescope. I think, if I'm not mistaken, it took about 180 hours. The Hubble Space Telescope, which is in orbit around the Earth, around 400 kilometers, I suppose, it was pointed at the same region of sky for about 180 hours. Okay, and then this image was captured. This is a visible light image, and you are able to see one of the earliest galaxies in the universe in this image. Of course, it is, while it looks aesthetically very pleasing, scientifically also it is extremely important, because now people can study actually the deepest image captured by Hubble. It captures a galaxy which is 13 billion light years away. I mean, slightly more than that, I would say. But that is probably one of the first galaxies which formed, because 13.7 billion years ago is what the universe or the Big Bang happened, and this was able to capture nearly 13 billion light years away. Now the fun part is, and what I have not included here, is something that's upcoming. It's called the James Webb Space Telescope. Now, this telescope is not going to be in Earth orbit. It is going to be much farther away. And it has a much, much larger mirror. Yeah, all telescopes tend to have mirrors these days, by the way, not lenses. This telescope can probably see the beginning of the universe as we know it, probably. I mean, it's that huge, and the resolution it provides and the kind of technology that has gone into it in the several years of its making. Okay, so now we enter our own neighborhood, our own Milky Way. Now, the image that you see here is actually of another galaxy. Now, naturally, we cannot, take a photograph of our own galaxy, because many of you may have seen the introductory video in which they announced that our Milky Way galaxy is 100,000 light years in width. I mean, from if you see the cursor here, if you go from this end to this end, then you will need 100,000, 1 lakh light years. I mean, that is an absolutely unimaginable number. You can't even go. I mean, the nearest star to the sun is 4 light years away. At the speed of light, the distance which is traveled in 1 year is a light year. So imagine, at the speed of light, 3 lakh kilometers per second you have to go, and for 4 years you have to keep doing that, and then you will reach Alpha Centauri, which is supposedly the Proxima Centauri, whatever they call it, which is supposedly the nearest star to our sun. Now imagine that. And this is what we call a spiral galaxy, a face on spiral galaxy. Face on because it is facing us, right? Galaxies are, in the universe, they are oriented here, there, everywhere. And well, lucky us that we have one which is very similar to, our own Milky Way, and it is facing us. This is what our Milky Way is supposed to look like. I always refer that, it looks like one of our favorite, at least South Indian snacks, called the chakli. Now you have these nice little spirals happening. There is a nice bright core, and the chakli's spirals, they are easy to refer to. These spirals are called spiral arms of the galaxy. They are originating from the center, and they keep, going outward like that in a beautiful manner. Now, why is our Milky Way galaxy so important? It's a humongous object in our universe, one of the largest galaxies. It's not something very tiny and insignificant, I would say. Now, the Milky Way actually began, as I earlier mentioned that these densities of gas and everything that was happening at the early stages of our universe. Well, this is the way our Milky Way started. It began as one of those several over densities of mass distribution in the universe very shortly after the Big Bang. Some of these, dense areas were actually the seeds for what we call as globular clusters. If you look at the image on the right-hand side, you see this huge, it's absolutely massive. The denseness of the whole object, you can see it is called, this example is called the Omega Centauri globular star cluster. It's a cluster of, millions of stars which are gravitationally bound, very closely packed, highly dense objects, which are actually present in the outer regions of any galaxy. In our Milky Way, this is actually one of the oldest star clusters of stars. Andre nakshatra punja anta helte in Kannada. So these globular star clusters are actually extremely good indicators of the age of a galaxy, and these are present on the outer regions, or what we call as the halo of the galaxy, where the density is very less, the number of stars and all are very less, and these globular star clusters are distributed all around the galaxy itself. Excuse me. Okay, now these globular star clusters, in which the oldest remaining stars in what is now the Milky Way formed. Okay, nearly half that matter in the Milky Way may have come from other distant galaxies. This is how it happens. Just like humans, we have a life cycle. We are born, we grow old, adolescence, and then middle age, and then we retire and we die, a few years down the line. And this is exactly how the universe works to stars, galaxies, everybody, they all have a life cycle. And these stars and clusters which, as I mentioned, comprise the stellar halo of the Milky Way. Within a few billion years of the birth of the very first stars, the mass of the Milky Way itself as a galaxy was so large enough that it was spinning relatively quickly. I mean, galaxies, we have the moon that goes around the earth, we have the earth that goes around the sun, and we know the other planets also go around the sun. We also know that the sun also goes around the center of the Milky Way. Okay, it's all gravity and orbits and other physical things that happen. And the Milky Way also goes around the center of the local group of galaxies. Okay. Now, what happens is, in physics, we call it as conservation of angular momentum. Because of this, I mean, the Milky Way is spinning and conservation of angular momentum is happening. And this led to the gaseous interstellar medium to collapse from a roughly spheroidal shape. The early Milky Way was not, the flat disk kind of a thing that we see, but rather a spheroidal shape. I mean, it's not a sphere as such, but a slightly, like a sphere, slightly probably egg-shaped kind of a thing. Now this, because of the conservation of angular momentum, it flattens out into a disk. Okay. Therefore, later generations of stars which formed were in this spiral disk itself. And younger stars, I mean, I've already told about, the life cycle of stars in brief. Including our sun. Our sun is only 5 billion years old. It's a very young G-type yellow small star. I mean, actually speaking, if I were to talk about the sun itself, it is a highly insignificant star in the whole scheme of things. Our sun also, if you were to consider its size or its position in the galaxy itself, is, well, practically non-existential, I would say, because we are not at the center of the Milky Way. We can't be at the center of the Milky Way due to other reasons, and the fact that our sun is a very tiny star, a G-type young yellow star. Okay, only 5 billion years old, and there are stars which are thousands of times bigger than our own sun. Perhaps you might have read recently, about a couple of months ago, that the Betelgeuse star in the Orion constellation has dimmed. That is a super red giant star. I mean, so many times be massive, absolutely. There is no, I mean, we cannot even compare, the sun and the Betelgeuse star. Our sun will one day become a red giant like the Betelgeuse, but I'll not talk about that. Okay. All right. The position of our sun in the Milky Way. Look at the image here. All right. We will see the structure of the Milky Way first. In the center, what we have is something called the Galactic Bar, or the galactic core. The core of the galaxy is in the center. Okay. Followed by that comes the Sagittarius arm. Let me digress a little bit here. In the summer, right, especially in the months of March, April, May, even June, July, if you were to find clear skies somewhere, especially in a village, towards the south or east southeast, if you look, you'll see one faint cloud-like thing in the sky. That is the one of the arms of the Milky Way, at least the part of the arm of the Milky Way, and it falls in the constellation of Sagittarius. Okay, so now Sagittarius is only a constellation. It's not something that's fixed. Constellations of stars are never fixed. These are just reference points and imaginary diagrams that people made up in the sky. Sagittarius is supposed to be a mythical creature, half horse, half man, holding a bow and arrow. Okay, but in reality, if you look at the Sagittarius constellation, it looks like a kettle. So that's the truth. And if you were to come to one of my stargazing sessions, I'll definitely point it out to you. All right. Every arm of the Milky Way, the chakli, the spiral of the chakli, each one of them has a name. When we look in the summer at that, that path of the stars in the sky, that is called the Sagittarius arm. And we are looking towards the core of the Milky Way. If you look at the cursor, the Sagittarius arm goes like that and comes right in front of our sun, like this. And we are here. Okay, the sun. The sun is in something called the Orion arm of the Milky Way. And then after us comes the Perseus arm and then the outer arm. There is one more arm called the Scutum Centaurus arm. Now, you don't have to take this very seriously, because this is not a lesson in astrophysics, but rather just making you familiar with the components of the Milky Way and the whole scale of things, right? You can, I mean, as human beings, we must understand and appreciate that we are the most intelligent species on earth, as we claim. We have hardly understood anything about our universe. Okay, there is a lot of things that is unknown to us, and we have come this far that we have been able to deduce that our own galaxy, the Milky Way, contains all these things, of course. But the Milky Way itself, as earlier found out, is not something that's alone. It's not a what do you say, an island in the universe, or that. Now we are scaling up the magnitude. You see, the Milky Way itself is 100,000 light years across. Okay, now you have other galaxies too in our universe. I mean, just imagine the scale. How many kilometers is that? I can't even imagine it. Right? So what is around our Milky Way? The Milky Way and its sister galaxy, as we can call it, the Andromeda Galaxy. If you go to a village, actually speaking, the Andromeda Galaxy is a naked eye object. You can see it as a faint smudge in the sky if you know where to look. Okay, in the modern day apps and all will show you where to look, and if you follow a star map also, it will tell you where to look. Nowadays, it's actually, if you go to, if at all you get a clear sky, it should be really nice up in the east at about 10 o'clock in the evening. You should be able to see it very well from a village. If you have a pair of binoculars, you can actually see it as a small, fuzzy blob in the sky with a binocular. And the telescope will show it to you slightly clearer. Anyway, the Milky Way and the Andromeda galaxies are a binary system of giant spiral galaxies. In fact, the Andromeda Galaxy, by the way, is the picture behind me over here. You see that? That is the Andromeda Galaxy, our sister galaxy. Okay, now these are part of a giant group of spiral galaxies of 50 closely bound, when I say bound, it means they are gravitationally bound, known as the local group. Okay, now the local group of the galaxy is part of something called the Virgo supercluster. I mean, I'll not even talk about numbers here. You are going from 100,000 light years to, huge, absolutely unimaginable numbers. But what I'm trying to say here is we are not alone. Our sun, the solar system, belongs to the Milky Way. We are all happy going around each other. And the Milky Way itself is one of the biggest galaxies in the local group, along with its sister Andromeda. And we all are part of something called the Virgo supercluster of galaxies. Okay. But you see, again, I'll come back to the Earth-Moon concept. Our Earth has the moon, and Jupiter has 64 of those, or something like that, and Saturn has as many, or if not more. Okay, and all planets tend to have satellites around them. But our own Milky Way also has satellites, satellite galaxies which are, much smaller compared to the 100,000 light year diameter of the galaxy that our Milky Way is. Okay, sorry, right. Two smaller galaxies, at least, called the Large Magellanic Cloud and the Small Magellanic Cloud. If at all you were to take a journey to Australia, or let's say Singapore, of that matter, and Singapore is a city, so it might not be very clear. Maybe, somewhere, any point below the equator, basically South Africa or other places, if it is dark enough, these two objects should be visible to the naked eye as nice fuzzy big blobs. In fact, just like how I explained, Andromeda Galaxy is a very tiny, fuzzy thing that is visible in the sky from a village. Well, these are much bigger to the naked eye itself. You can see them as fuzzy patches in the sky, and these are galaxies by themselves. Okay, they will definitely have planets in them, and several sun-like stars and other things that happen. But unfortunately, I mean, I know this question is probably going to come at the end of the lecture itself. Is there life in the universe? That's a very common question. When we talk about galaxies, when we talk about planets and stars and other things, right? The question naturally comes, are there aliens? Well, probably there are. If we are here, then probably they are there somewhere else. But unfortunately, it's the speed of light that dictates everything else. We cannot communicate with them, pick up a cell phone and say, hello, how are you? Just doesn't happen, because that the radio wave that has to go there travels at only a finite speed, 3 lakh kilometers per second. And let us say, um, if Alpha Centauri or Proxima Centauri had a planet around it which had life, then probably, if I were to transmit something, a message to them saying that, come visit us and anything like that, then after 4 years the message will reach them. And once they say, acha, fine, we are going to come to you, it will take another 4 years to reach us. So I mean, just with the nearest star, the communication is going to be so slow. Imagine if at all there is life elsewhere in the universe, how slow the communication is going to be. Not in our lifetimes, at least. And if at all we humans don't manage to kill ourselves, in the next couple of years, then probably several generations down the line, advanced human beings may perhaps receive some message from alien beings, extraterrestrials. Okay, this is important because we need to talk about that when we talk about such things like, satellite galaxies and other things, because humans are evolving and technology is evolving, and it's highly important that we think about future, much ahead into the future itself, right? So these two galaxies, if at all you go take a trip to Australia or South Africa, you should be able to see it with the naked eyes, right? So going ahead, actually speaking, the proof of the Milky Way, which that it contains so many stars and everything, came in 1610, when Galileo Galilei used one of his very basic telescopes. He was not the first person to invent the telescope. That's a completely different story. Okay, he was probably one of the first people to point it at the right thing in the sky, at the moon, at Jupiter, and the Milky Way itself. Okay, he discovered that it composed of a huge number of faint stars, right? What happens is, basically, his telescope was only the lens of his telescope was just 2 inches across. Okay, and it was huge, and it has several issues. I mean, you're talking about 1600s, okay, the 17th century, and lens making technology had not yet evolved to an extent where you could have high resolution. But physics states that the bigger the physical diameter of your lens or the mirror or whatever you're using, the more the resolution it has. Okay, the more easily it can resolve the 2 points of light, I mean, which is further away. So that's the whole scheme of things here. And therefore, the world's biggest telescope, I mean, imagine the Galileo's telescope was only 2 inches across the lens. The biggest refractor telescope in the world, which is not being used anymore, has a 1 meter diameter lens. I can't even show it on the screen. A 1 meter diameter lens. And the biggest telescope now currently functioning is the Keck Observatory, which has a 10 meter diameter mirror. Okay, that technology is completely different. Probably some other day I'll give a talk on telescopes and how they work. Okay, so imagine the Hubble Space Telescope, which is there, has a 2.3 meter diameter mirror. So the bigger the size of the objective lens or mirror it is, the higher the resolution. Okay, so Galileo that time itself was able to resolve. That is what I was coming to, actually, by talking about resolution. He was able to see more than his eye could see. Okay, just naked eye itself, if you go to a village, you can see thousands of stars. Now, if you point a telescope at that, some faint object in the sky, it will resolve it into more stars. Okay. Now, Galileo Galilei did that. Then, in a treatise in 1755 by Immanuel Kant, okay, drawing on earlier work by Thomas Wright. We don't have to know about who these scientists actually were back then. Okay, they correctly speculated that the Milky Way might be a rotating body of a huge number of stars, held together by gravitational forces which are similar to the solar system but on a much larger scale. I mean, mid 18th century, and people are already talking about, you know, the Milky Way being the huge thing similar to the solar system bound by gravity. The first attempt to describe the shape of the Milky Way and the position of sun within it was carried out by William Herschel. William Herschel started out as a music conductor in an orchestra in the King's Court, I mean the English court, court of England, and then he goes on to become astronomer royal. And he discovers several things. He had huge telescopes and other things, and among his other discoveries was the discovery of Uranus, planet Uranus. Okay, now this gentleman, he was one of the first to make an attempt at describing the shape of the Milky Way by carefully counting the number of stars in different regions of the sky. He produced a diagram of the Milky Way with the solar system close to the center. That was a very unfortunate, but that was how it was with the available technology at that time, right? I'm almost nearing the end, in fact. Edwin Hubble, again we come back to him, in the early 1920s, right, using a 2.5 meter, see these numbers keep coming, and you must accept the fact that, you know, the telescopes are huge here when you're talking about it. In 1920s itself, there was a 100-inch telescope. The mirror of the telescope itself is 100 inches in diameter, right? With that kind of a light gathering power, he was able to produce astrophotos, something that I love to do. I take astrophotos and, you know, can see things which are never going to be visible to my eye. Okay, now this kind of astrophotos, they actually revealed, okay, rather resolved the outer parts of some of the spiral nebulae. You know, they were not called galaxies until then, they were called nebulae. In fact, the Andromeda Galaxy was actually called the Great Andromeda Nebula earlier in those times, right? This scientist Edwin Hubble, he actually says that these are actually other galaxies, right? He found that because the Andromeda Nebula is 2 million light years away. I mean, that's huge. Again, what we are talking about, light traveled in 1 year, the distance, right, multiplied that by 2 million, right, that 2 million light years away. Okay, it is far too distant to be part of our own galaxy and is therefore another galaxy, right? On the right, you will see an image. If you go to a village and all that, this is what you should be able to see. Rather, with our human eyes, this will be slightly fainter, but this is how you will see part of our Milky Way, right? When you're looking at this image, you will see it almost exactly as it is. This is what I mentioned by the Sagittarius arm of our Milky Way galaxy. Okay, for those of you who can understand the star names in Kannada, over here, if you see the cursor over here, that is called the Jyeshtha Nakshatra, right? Or in Hindi also, I think it's still called the Jyeshtha Nakshatra. So towards this region, the denseness, you see this cloud here, it's a photo, of course, a long exposure photograph. But even with your eye, you might frequently, if you're not used to it, you might get confused that it is a rain cloud. It looks like that, very dense. But if you take up even a simple pair of binoculars and look at it, you will now see thousands of stars in it. And if you take a telescope, it will obviously get resolved into thousands of stars more, right? So that it is. And the brown things that you see are galactic dust and other things, opaque things behind which there are stars, but the stars are not, I mean, the light is not able to pass through. So that is what you see there, the galactic, the dust and other things, right? So, and the bright regions contain millions and millions of stars, right? Okay, so this is how you will see it from a village and other things. Okay, so we are at the absolute end now. I know it was a very short lecture. As I said, I would highly recommend that you go to a village and after nightfall look up at the sky, because this is how many of amateur astronomers and astronomers, you know, like myself, I'm an amateur astronomer. We started off in 97, 98, when I was in Kerala, in my aunt's house, we could, because of power cuts, we would go outside. And it was the summer, it was too hot to stay inside, right? So we went out, and you can see thousands of stars there. There is absolutely no light. It is a village far away from the city. At least the nearest city was more than 40 kilometers away. So you can only imagine how dark it gets there. And you will then see that path, right? Whatever I showed you here, you will see this pathway of the stars, pathway of the Milky Way itself. I mean, it's such an emotional experience, I'll tell you. It's only when you do it that you will feel it. So that's the thing. We will definitely realize, what we humans are. That we are hardly a significant part. We are very insignificant when it comes to the sizes of the universe, and yet the most important part is being the most intelligent creature on planet Earth. We should make very good use of this intelligence and discover more about our universe in the years to come, in the decades to come, right? Our generation, the one after that, and all that. And once you realize this, you will see life in a whole new light. So that's about the end. A very short lecture, but I hope you all enjoyed it and came to know about certain new facts about our Milky Way galaxy. It's not just our Milky Way galaxy. Other galaxies also have similar properties, and they all go around each other, and that's the dance of the universe, right? So thank you so much for Mr. Dinesh to giving me this opportunity, because I love talking about astronomy, and hopefully next time my topic will be something else. Let us see what you all will demand, and I'll probably speak about that. So thank you so much once again.
Thank you, Satya. Great session. I think quite an exciting. There's so many things to know, and we worry about small things on a day-to-day basis, and we are so irrelevant in this such a huge. I know some of us start thinking. I many times start thinking. ನಮ್ಮ ಬಸವೇಶ್ವರ ಅವರು ಶಂಕರಾಚಾರ್ಯರು ಇದ್ದಾಗ ಎಷ್ಟೋ ಆಗಿನ ಕಾಲದಲ್ಲಿ ಬಿಟ್ಟ ಲೈಟ್ ಈಗ ಮುಟ್ತಾ ಇದೆ ಎಷ್ಟೋ ಸ್ಟಾರ್ಗಳಿಂದ ಅಂತ. ಈಗ ಎಷ್ಟೋ ಸ್ಟಾರ್ಗಳು ಸತ್ತು ಹೋಗಿರ್ಬೋದು. They might have become black holes by now, but we are still seeing them. And this is really such an interesting topic. Really, I think we should throw open this session to audience here. I would invite people to ask question here. I think we have already one gentleman, Shubham Srivatsava.
Good evening,
Go ahead, Shubham. Yeah, Shubham.
Sir, it's a great time for me to join this session because this is my first session and I was invited by Sir Satyakumar Sharma. So
Okay.
thank you first of all. Sir, now come to the point. My main concern regarding the PPT is this. Firstly, we have a slide of the Hubble image. So sir, I want to ask one thing that approximately the telescope was located at 575 kilometers from the Earth.
Your voice is breaking up very
I want
much.
to know that that
Shubham, your voice
Hello?
is breaking. You're not clear. Why don't you type in your question?
wait, sir.
Yeah, now you can go ahead.
Okay, sir. Okay, I will try.
No, you can
Okay,
go
sir,
ahead
okay.
now. It's slightly better.
Okay, sir. So my main question is that Hubble is located approximately 575 kilometer above the Earth lithosphere. So and there are so many asteroid belts also, and out of the solar system there is a auto cloud which is made up of ice. So I want to know this that why the light is not blocked by these stellar objects.
Okay. First of all, when we talk about the Oort cloud or the asteroid belts and everything, We typically depict them as a dense thing, that's in between Mars and Jupiter, or the Oort cloud, which is beyond Pluto and all that. But the reality is different. And the field of view of the Hubble, compared to the gap in between those two objects, let's say there are two objects flying around, and the gap in between them is so huge. And the field of view of this Hubble Space Telescope is so tiny. Okay, I mean, if at all I were to show you at a later time, the actual area of the sky that the Hubble actually observed is so small. Okay, that these things won't matter, actually speaking. The gap in between these things are so large. There is actually so much space over there, empty space, that the Hubble can actually look through. I mean, none. To tell you the truth, these objects don't block the starlight. So that should answer your questions. No, neither the asteroid belt nor the Oort cloud will block the starlight.
Thank you, Satya. We have Rachna Arbati. Can you unmute Rachna Arbati?
Yeah. Hello, sir. Firstly, it was a very interesting session on such a vast subject. I thoroughly enjoyed it. Now, my question to you is it a myth that Andromeda Galaxy and Milky Way is going to collide in about 4 billion years? And if that is the case, then what would be the consequences? Like, for example, will it perish, or will the stars combine? That
Okay.
was just a basic question. Yeah.
Rachna,
Yeah.
I would like you to introduce yourself. That would be helpful.
Oh, sure, sir. Yeah, I'm Rachna Arbati. I'm working as a science teacher in Sri Aurobindo Memorial School for grade 6 in Bangalore.
Oh, wonderful.
Yeah.
Nice to hear that, Ms. Rachna.
Yes, sir.
Okay. So I think that's a perfectly timed question, because I can start my answer from the previous answer. Okay.
Oh, yeah. Okay.
Right. You see what I said, the nearest star to us is 4 light years away. So you can only imagine how much gap is there, right? So it's not a myth that, the Andromeda Galaxy and Milky Way will merge into each other. All right. So it is true. They are being gravitationally attracted, and they will merge. Okay. The best, one of the best, what do you say? The cannibal. I mean, what happens is, when these galaxies merge, there is a lot of gravitational interaction that happens and everything. And Milky Way or the Andromeda Galaxy, as we know it, they will change shape. Okay. They might turn into something really awkward looking. If you were to Google for something called the antennae galaxies, that will answer your question, what they are supposed to look like after, I mean, it won't look exactly like that, but something of those forms. Or the Whirlpool Galaxy. The Whirlpool Galaxy has a smaller galaxy right next to it, and they are merging into each other. And there is this, you can see the merging that's happening. It's a face-on spiral galaxy, and from the smaller galaxy, the matter is being attached to the bigger galaxy itself. So when the Milky Way and the Andromeda Galaxy merge into each other, things will just go past each other, or they can collide. A lot of things can happen because of, the gravitational interactions that is happening. And a little bit of destruction will happen. Things will change. We won't know it. So yeah, but it's not a myth at all. Andromeda and Milky Way will merge into each other, and hopefully it will be as little destructive as possible. So that's the whole thing. In 4 billion years, if that should happen, then our sun will still be around, and our solar system will be cooking, so glory be. And so because our sun would have become a red giant, or will be well on its way towards its end. Because the sun is expected to last another 5 years. So when all of this happens, the humans would have, gone far, far away. But yeah, you are right. Andromeda and Milky Way will merge, and the merger will take place. I mean, as per the other mergers that are visible in the universe currently.
Thank you so much, sir. I'll definitely look into that antenna galaxy, because I'm interested in that. Thank you. And thank you, Tare Zameen, for giving such a wonderful, webinars every week. I try and attend most of those. Thank you so much, sir. Thank you.
Thank you, Rachna. We have Mahesh here. Mahesh, you can ask your question.
Hi, can you hear me?
Yeah.
Hello?
Yeah, Mahesh.
Yeah,
Please
hi.
introduce
This is Mahesh Shetty. I'm in from Bangalore, student of Satya. So I got a link from him, so I attended. Thanks both Dinesh and Satya for the session. Satya, my question is like you told like the width of the galaxy is 10,000 light years. Like
100,000,
those are
100,000 light years.
sorry,
1 lakh.
1
sorry,
lakh
yeah.
light years.
1 lakh light years. So those are like huge numbers. Like how do they come to that conclusion? Because there is no way to, like, we cannot see that is like light coming and going there, or like how do they make all those numbers? Like how accurate they are? How to
Well,
even visualize?
you cannot visualize it as such because all these
Mhm.
numbers are only got through scientific experiments. You might want to look up something called the redshift of stars and other things. I mean, this is how you measure how you, from basically the redshift is where you can measure how fast something is going away from you. Okay, and from that you can calculate its distance. You can calculate other properties also if you're looking at a star or something else, some galaxy or something like that. But when you observe these objects at the very far end of the galaxy, let's say for example that Omega Centauri that I showed you there, if you were to study the stars over there, okay, if you were to study their type, you will know how old they are. And from that, there are several other deductions that happen, and you end up at the distance of the stars. And they study, things like what we call as variable stars, something actually speaking, something called Cepheid variable stars. They studied them, they studied the redshift, and all the data from these studies that come together, you can talk about the distance, age,
Oh,
other things.
okay. Okay. Yeah. Thank you.
Satya, you can unshare the slide. I think
Yeah, I think I'll unshare. Sorry, yeah.
So we have next question from Srijan.
Good
Yes.
evening, sir.
Sir, good evening, sir.
Yeah. Good evening.
Sir, Satya sir, it's an excellent explanation and great quality of slides, sir.
Thank you.
ಸರ್ ನಾನು ವಿಜಯ್ ಕುಮಾರ್ ಅಂತ ಹೇಳಿ ಬಾಗಲಕೋಟೆಯಿಂದ ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ.
ಹೇಳಿ.
ಶಂಕರಪ್ಪ ಸಕ್ರಿ ಪ್ರೌಢಶಾಲೆ ವಿಜ್ಞಾನ ಶಿಕ್ಷಕ. ಸರ್, ನಾನು ಒಂದು ಕ್ವಶನ್ ಏನಂದ್ರೆ ಕಾಸ್ಮಿಕ್ ಕ್ರಂಚ್ ಬಗ್ಗೆ ಕೇಳ್ತಾ ಇದ್ದೆ. ಸೊ ಅಕಾರ್ಡಿಂಗ್ ಟು ರೆಡ್ ಶಿಫ್ಟ್, ದ ಯೂನಿವರ್ಸ್ ಇಸ್ ಎಕ್ಸ್ಪಾಂಡಿಂಗ್, ಆಸ್ ವಿ ಆಲ್ ನೋ. ಇನ್ ಸರ್ಟನ್ ಟೈಮ್ ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಾಪ್. After that, it collapse again where it started. So this phenomenon is called as cosmic crunch. Can you elaborate on this? Enlighten, please.
ವೆಲ್, ಏನು ಅಂತಂದರೆ ಬೇಸಿಕ್ಲಿ ದ ಬಿಗ್ ಕ್ರಂಚ್ ಅಂತ ಕೇಳ್ತೀವಿ, ದ ಬಿಗ್ ಬ್ಯಾಂಗ್ ಅಂತ ಹೇಳ್ದಂಗೆ ದ ಬಿಗ್ ಕ್ರಂಚ್ ಅಂತ. ನಾವು ದಿಸ್ ಇಸ್ ಎ ಸಾರಿ
cosmic crunch.
The big crunch. Okay, cosmic crunch, big crunch, whatever it is, it's a part of cosmology.
Yes,
it is a hypothetical scenario, ಆಯ್ತಾ, as we say it, of the ultimate fate of the universe. ಈ ರೆಡ್ ಶಿಫ್ಟ್ ಎಲ್ಲ ಇದು ಮಾಡಿದಾಗ ಪ್ರಾಬಬ್ಲಿ ದ ಸಿನಾರಿಯೋ dictates that everything will then come together into one big crunch, ಎಲ್ಲ ಸೇರ್ಕೊಂಡು ಒಟ್ಟಿದಾಗ ಹೋಗ್ಬಿಡುತ್ತೆ ಅಂತ ಅಂದ್ಬಿಟ್ಟು. Okay.
Yes, sir.
In which the expansion of the universe reverses and the universe
Yes,
recollapses.
it's the reverse process of expansion.
Yes, howdo, exactly. Ultimately causing the the whole scale factor to reach a 0 point. Okay.
Yes,
So that is the thing. Adr bagge helodike I'm afraid I am not competent enough because I'm not a cosmologist. All I would probably say that I know as much as you know about it. Now news in the end keltivo, the day-to-day updates that we get from the internet, that is all probably that I could also tell you about it, because I'll admit my field of what do you say, liking is more general. As an amateur astronomer, I don't look at the specifics. Andre, frankly speaking, I don't look at theories. Cosmology is something you need to, it's an acquired taste anta helbodu, aita. And I'm afraid I'll admit I'm not much into cosmology, but I know as much as you know about it.
Actually, most of the discussion is done by amateurs only.
Yes, actually, yeah, we talk a lot about things, but if we were to approach cosmologists, then they will tell you all the theory that we,
Okay, sir. Thank you very much, sir.
Thank you, Vijay Kumar.
Thank you, Dinesh sir. Thank you very much.
Srijan Kulkarni ಅವರು next question ಕೇಳ್ತಿದಾರೆ. Srijan Kulkarni is at
Yes, sir.
Srijan?
Yes, sir.
Yeah, go ahead.
Good evening, sir. I'm Srijan Kulkarni. I'm 14 years old. My question was that how did the Milky Way get its name?
Now for that you should look at Greek mythology. Okay. You see, if you were to look at how it got its name, then I started with this one itself in the beginning, right? Greek goddess Hera antanbittu. It's a nice thing. I mean, it's all about storytelling, and each culture or each civilization has a way of telling their own story, right? So if you were to talk about it in Babylonian, sorry for the pronunciation, there is a poem called Enuma Elis. Okay, in this the Milky Way is created. I told you about Hera, the goddess Hera, and her milk is what the flows is called the Milky Way, right?
Yes, sir.
But in the Babylonian poem Enuma Elis, the Milky Way is created from the cutout tail, okay, of the salt water ಅಂದ್ರೆ ಸಿ ಸಮುದ್ರದಲ್ಲಿ ಇರೋ ಡ್ರ್ಯಾಗನೆಸ್ ಅಂದ್ರೆ ಫೀಮೇಲ್ ಡ್ರ್ಯಾಗನ್ ತಿಯಾಮಾತ್ ಅಂತ ಅಂದ್ಬಿಟ್ಟು, and then it was set in the sky by Marduk, the Babylonian national god. Okay, they have a national god. After he kills her, he cuts off her tail and puts it in the sky, and that is called the Milky Way for them. There are other stories like this, you know. ನಮ್ಮ ಇದರಲ್ಲೇ ನಾವು ಅದಕ್ಕೆ ಕ್ಷೀರಪಥ ಅಂತ ಹೇಳ್ತೀವಿ ಅಲ್ಲ, ಸೊ ದ ಮಿಲ್ಕಿ ವೇ. ಬಟ್ ಅವರ್ ಓನ್ ದಿಸ್ ಒನ್ ವಿ ಶುಡ್ ಪ್ರಾಬಬ್ಲಿ we should what do you say, the mythology as we say it, we should explore our own stories and talk about it, because in Greek mythology the Milky Way was formed after the there is a god in there, this one called Hermes. Okay, he is a trickster god. Okay, he tries to drink the milk of Hera, the goddess, the queen of the goddess, while she was asleep. Okay, when she woke, you know, the milk from her chest gets splattered across the heavens, and that becomes the Milky Way. So these are all stories which are created by humans everywhere. So we have our own stories, they have their own stories, each culture will have their own stories, from one tail of a dragon to the milk of the god. So that is how
Satya, ಭಾರತದ್ದು ಏನಾದ್ರೂ ಕಥೆ ಇದೆಯಾ? ಭಾರತದ್ದು ಇಷ್ಟೊಂದು ಹಳೆಯಿಂದ ಎಲ್ಲರೂ ಇದಿದೆ, ಕ್ಷೀರಪಥದ ಬಗ್ಗೆ ಏನಾದ್ರೂ ಕಥೆ ಇದೆಯಾ?
I'll admit, ನಾನು ನಮ್ಮ ಭಾರತದ ಬಗ್ಗೆ ಅಷ್ಟೊಂದು ತಿಳ್ಕೊಂಡಿಲ್ಲ. ನಾವು ಹೊರಗಿನವ್ರದ್ರ ಬಗ್ಗೆ ತುಂಬಾ ತಿಳ್ಕೊಳಕ್ ಹೋಗ್ತೀವಿ, ಬಟ್ ಅನ್ಫಾರ್ಚುನೇಟ್ಲಿ ದಟ್ ಇಸ್ ವಾಟ್ ಐ ಇಂಡಿಕೇಟೆಡ್, ದಟ್ ನಮ್ ಕಥೆನೇ ನಾವು ನೋಡಕ್ ಹೋಗಲ್ಲ ಅಂತ.
I think we should organize one session on how India was, like, ahead of the curve in the past, especially on astronomy. ಯಾಕಂದ್ರೆ ಎಷ್ಟೊಂದು ನಾವು ನಮ್ಮ ಗ್ರಂಥಗಳಲ್ಲಿ ಇದ್ರ ಬಗ್ಗೆ ಉಲ್ಲೇಖ ಇದೆ. I think that is another session I think we should do. ಈಗ ರೂಪಾ ಅವರು ಒಂದು ಪ್ರಶ್ನೆ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ರೂಪಾ, ನಿಮ್ಮನ್ನ ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ಕೋಬಹುದು ನೀವು.
ಹಲೋ ಸರ್.
Hello, good evening, sir.
Good evening.
Good evening, sir. A well presentation, sir.
Thank you.
ಸರ್, ನನ್ನ ಕ್ವೆಶ್ಚನ್ ಏನಂದ್ರೆ, ನಾನು ಟೀಚರ್ ಆಗಿದ್ದೇನೆ ಸರ್ ಮೂಡುಬಿದ್ರೆಯಲ್ಲಿ. ನನ್ನ ಕ್ವೆಶ್ಚನ್, ಈ ಗ್ಯಾಲಕ್ಸಿ ಅಂತ ಹೇಳಿದ್ರೆ ಬಿಲಿಯನ್ಸ್ ಆಫ್ ಸ್ಟಾರ್ಸ್.
ಹೌದು.
ಆದ್ರೂ ಸರ್, ಆ ಸ್ಟಾರ್ಸ್ ಇರುವಂತಹ ಪ್ರದೇಶ ಗ್ಯಾಲಕ್ಸಿಯಲ್ಲಿ ಆ ಚಿಕ್ಕ ಚಿಕ್ಕ ಗ್ಯಾಲಕ್ಸಿಯನ್ನು ನಾವು ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು ಸರ್?
ಈಗ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, ಓಕೆ, ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ನನಗೆ ಮೂಡುಬಿದ್ರೆಗೆ ಒಂದು ಒಳ್ಳೆ ಕನೆಕ್ಷನ್ ಉಂಟಾಯ್ತಾ. ನಾನಲ್ಲಿ ಮಹಾವೀರ್ ಕಾಲೇಜಿಗೆ ಬರ್ತಾ ಇರ್ತೇನೆ.
ನನ್ನ ಮಗ ಮಹಾವೀರ್ ಕಾಲೇಜ್ ಸ್ಟೂಡೆಂಟ್ ಸರ್ ಈಗ ಪ್ರೆಸೆಂಟ್.
ರಮೇಶ್ ಭಟ್ರನ್ನ ಮೀಟ್ ಆಗಿ, ಅವರು ತುಂಬಾ ಒಳ್ಳೆ ಅಮೆಚೂರ್ ಆಸ್ಟ್ರೋನಮಿ ಇದೆಲ್ಲ ಹೇಳ್ಕೊಡ್ತಾರೆ
ಸರ್. ನನಗೆ ಒಳ್ಳೆ ಕಾಂಟ್ಯಾಕ್ಟ್ಸ್ ಅವ್ರ ಜೊತೆಯಲ್ಲಿ.
ರಮೇಶ್ ಭಟ್ರು ಬರೋರಿದ್ರು ಜೊತೆಯಲ್ಲಿ. ಇನ್ಫ್ಯಾಕ್ಟ್ ಅವ್ರಿಗೆ ಇನ್ವೈಟ್ ಮಾಡಿದ್ದೆ ನಾನು.
Oh, very nice. He speaks really well, and in Kannada especially. He was one of the first ones to do radio program about astronomy in
sir, I attended so many programs, sir.
Yeah, we are very close. ಎನಿವೆ, ನೀವು ಕೇಳಿದ ಪ್ರಶ್ನೆಗೆ ನಾನು ಏನು ಹೇಳ್ತೀನಿ ಅಂದರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸ್ಟಾರ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಡಿಸ್ಟಿಂಗ್ ಫ್ರಮ್ ಅದರ್ ಗ್ಯಾಲಕ್ಸೀಸ್. ಆಯಿತಾ, ಇಷ್ಟೊಂದು ಬಿಲಿಯನ್ಸ್ ಆಫ್ ಸ್ಟಾರ್ಸ್ ಇದೆ. ಬಟ್ ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ತಿದ್ರೆ, ಐ ಮೀನ್ ಏನು ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಈ ನಾನು ದೊಡ್ಡ ದೊಡ್ಡ ಟೆಲಿಸ್ಕೋಪ್ಗಳ ಬಗ್ಗೆ ಹೇಳಿದ್ನಲ್ಲ, ದ್ಯಾಟ್ ಈಸ್ ದ ಕೀ ಹಿಯರ್. ಆ್ಯಂಡ್ ಅನದರ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಕಾಲ್ಡ್ ದ ಸ್ಪೆಕ್ಟ್ರೋಗ್ರಾಫ್, ವಾಟ್ ಎವರ್ ಯು ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್. ಆಯಿತಾ? ಸೊ ಏನಾಗುತ್ತೆ, ಸ್ಮಾಲ್ ಟೆಲಿಸ್ಕೋಪ್ ಕೆನಾಟ್ ಡಿಸ್ಟಿಂಗ್ವಿಶ್ ಬಿಟ್ವೀನ್ ದ ಸ್ಟಾರ್ಸ್ ಆ್ಯಂಡ್ ದ ಗ್ಯಾಲಕ್ಸೀಸ್. ಲೆಟಸ್ ಒಂದು ಚಿಕ್ಕದು ಅಂಗೈ ಅಗಲದ ಟೆಲಿಸ್ಕೋಪ್ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಅದರ ಲೆನ್ಸ್ ಏನಾದರೂ. ಮೇ ಬಿ ಇಟ್ ಕೆನಾಟ್ ಡಿಸ್ಟಿಂಗ್ವಿಶ್. ಇಟ್ ಕ್ಯಾನ್, ಐ ನೋ ಫಾರ್ ಶ್ಯೂರ್ ಸರ್ಟನ್. ಏನಕ್ಕೆ ನಾವೆಲ್ಲ ಅಮೆಚೂರ್ ಆಸ್ಟ್ರೋನಾಮರ್ಸ್, ನಾವು ನೋಡ್ತಾ ಇರ್ತೀವಿ. What happens is, a star, when you focus light, star in the light, let's say it's coming from infinity and parallel rays of light come, and when it passes through a lens or reflects off the surface of a mirror, it focuses to a single point. On the point source tara kanuttadu. Okay, but now that all astronomical objects have been catalogued pretty much very extensively, extremely deep, highly detailed catalogs ಇದೆ. ಇದರಿಂದ ನೀವು ಒಂದು ಆಬ್ಜೆಕ್ಟ್ನ, ಗ್ಯಾಲಕ್ಸಿನ ಪಿಕ್ ಮಾಡಿದ್ರಿ ಅಂತ ಹೇಳಿ, ಇಫ್ ಯು ವೇರ್ ಟು ಲುಕ್ ಈವನ್ ಥ್ರೂ ಎ ಸ್ಮಾಲ್ ಟೆಲಿಸ್ಕೋಪ್, ಇಫ್ ಯು ವೇರ್ ಟು ಲುಕ್ ಎಟ್ ದಟ್ ಆಬ್ಜೆಕ್ಟ್, ಯು ಕ್ಯಾನ್ ಇನ್ಸ್ಟೆಂಟ್ಲಿ ಡಿಸ್ಟಿಂಗ್ವಿಶ್ ದಟ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಅ ಸ್ಟಾರ್. ಏನಕ್ಕೆ ಅಂದರೆ, ಸ್ಟಾರ್ಸ್ ವಿಲ್ ಲುಕ್ ಲೈಕ್ ಅ ಬ್ರೈಟ್ ಪಾಯಿಂಟ್ ಆಫ್ ಲೈಟ್. ಓಕೆ, ವೆರಸ್ ಅ ಗ್ಯಾಲಕ್ಸಿ ವಿಲ್ ಲುಕ್ ಸ್ಲೈಟ್ಲಿ ಔಟ್ ಆಫ್ ಫೋಕಸ್, ಅಂದರೆ ಒಂಥರ ಫಝಿ ಥರ ಕಾಣಬಿಡುತ್ತೆ. ದ ಗ್ರೇಟೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಇಸ್ ದ ಆಂಡ್ರೋಮೆಡಾ ಗ್ಯಾಲಕ್ಸಿ. ನಿಮ್ಮ ಹತ್ರ ಬರೀ ಒಂದು ಸಿಂಪಲ್ ಬೈನಾಕ್ಯುಲರ್ ಇಟ್ಕೊಂಡು, if you know where to look for Andromeda Galaxy, and in which case you can easily ask Dr. Ramesh Bhatt, he can show it to you. And when you look at it, you will immediately know it's a galaxy. Andre, it is not a star ಅಂತ ಅಂದ್ಬಿಟ್ಟು. Now, larger the telescopes, ಇವಾಗ ಕೇಕ್ ಅಬ್ಸರ್ವೇಟರಿ ತಗೊಳ್ಳಿ. We have gone from a ಅಂಗೈ ಅಗಲದ ಲೆನ್ಸ್ ಇಂದ ಬಿಟ್ಟು, we are now going to a mirror which is 10 meters in diameter. ಆಯ್ತಾ? ಸೊ ಇಷ್ಟು ದೊಡ್ಡ ಸೈಜ್ಗೆ ನಾವು ನೋಡ್ತಾ ಇದ್ದ ಹಾಗೆ ಏನಾಗುತ್ತೆ, ಇಟ್ ಕ್ಯಾನ್ ರಿಸಾಲ್ವ್ ಸ್ಟಾರ್ಸ್ ಇನ್ ದ್ಯಾಟ್ ಗ್ಯಾಲಕ್ಸಿ. ನಮ್ಮ ಗ್ಯಾಲಕ್ಸಿನಲ್ಲಿ ಮಾತ್ರ ಅಲ್ಲ, ಆ ಗ್ಯಾಲಕ್ಸಿನಲ್ಲಿ ಇರೋ ಸ್ಟಾರ್ಸ್ನ ರಿಸಾಲ್ವ್ ಮಾಡುತ್ತೆ. ಅಷ್ಟೊಂದು ರೆಸಲ್ಯೂಷನ್ ಇರುತ್ತೆ ಆ ಟೆಲಿಸ್ಕೋಪ್ಗೆ. ಓಕೆ, ಸೊ ಇಫ್ ಯು ವೇರ್ ಟು ಟೇಕ್ ದ ಜೇಮ್ಸ್ ವೆಬ್ ಸ್ಪೇಸ್ ಟೆಲಿಸ್ಕೋಪ್ ಅಂತ ಈಗ ಸದ್ಯದಲ್ಲೇ ಹಾರ್ಲಿಕ್ಕಿದೆ ಅದು ಸ್ಪೇಸ್ಗೆ, ಅದನ್ನು ತಗೊಂಡ್ರು ಕೂಡ ಅಷ್ಟೇ. Imagine it's flying in space, so Earth atmosphere the yav distortion iralla, it is so far away from Earth. It can also resolve details in other galaxies. So that is how you distinguish between stars and galaxies. Idan nodidre idi galaxy, adu nodidre adu star anta helo idralli idirbeku. For example, nanaga Omega Centauri anta ತೋರಿಸಿದೆ. ನಾನು ಇಲ್ಲಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಬೆಂಗಳೂರಿಂದ ಒಂದು 70 ಕಿಲೋಮೀಟರ್ ದೂರದಲ್ಲಿ ಒಂದು ಹಳ್ಳಿ ಪ್ರದೇಶಕ್ಕೆ ಹೋಗ್ತೀನಿ ನಕ್ಷತ್ರ ವೀಕ್ಷಣೆ ಮಾಡೋದಕ್ಕೆ. ಅಲ್ಲಿ ಒಮೆಗಾ ಸೆಂಟೋರಿ ಇಸ್ ನೇಕೆಡ್ ಐ. ಬೆಂಗಳೂರಿಂದ ಅದು ಕಣಿಗೆ ಕಾಣಿಸಲ್ಲ, ಬೈನಾಕ್ಯುಲರ್ ಅಲ್ಲಿ ಕಷ್ಟದಲ್ಲಿ ಕಾಣಿಸಿದ್ರೆ ಅದು ದೊಡ್ಡ ವಿಶೇಷ. ಬಟ್ ಆ ಹಳ್ಳಿಗೆ ಹೋದಾಗ ಜಸ್ಟ್ 70 ಕಿಲೋಮೀಟರ್ಸ್ ಅವೇ ಆ ನಕ್ಷತ್ರ ಪುಂಜ ಇದೆಯಲ್ಲ, ಗ್ಲೋಬುಲರ್ ಸ್ಟಾರ್ ಕ್ಲಸ್ಟರ್ ಇಸ್ ನೇಕೆಡ್ ಐ. ಐ ಕ್ಯಾನ್ ಇಮಿಡಿಯೇಟ್ಲಿ ಸೇ ಟು ಆಲ್ ಮೈ ಅಟೆಂಡೀಸ್, ಅಲ್ಲಿ ನೋಡಿ ದಟ್ ಯು ಸಿ ದಟ್ ಫಸ್ಟ್ ಬಾಲ್ ಅಂತ ಹೇಳಿದಾಗ ಅವರು ಹೂ ಅಂತ ಅಂತಾರೆ. ದಟ್ ಇಸ್ ಒಮೆಗಾ ಸೆಂಟೋರಿ ಗ್ಲೋಬುಲರ್ ಸ್ಟಾರ್ ಕ್ಲಸ್ಟರ್. ಇತ್ಲ ಕಡೆಗೆ ನೋಡಿ ಆಂಡ್ರೋಮೆಡಾ ಗ್ಯಾಲಕ್ಸಿ ಕಾಣುತ್ತೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಅದೆಲ್ಲ ನೇಕೆಡ್ ಐ ಅಲ್ಲಿ ಕಾಣುತ್ತೆ. And the bigger the telescope you have, the more resolution you have, and therefore the more details you can, the more points of light you can separate in each galaxies. So I hope I have answered your question correctly.
Yeah, I think I have just unmuted her. Thank you, Rupa avare. ಈಗ ಕಡೆ ಒಂದು ಪ್ರಶ್ನೆ ಕೇಳೋಣ. ಶುಭಂ ಮತ್ತೆ ಇನ್ನೊಂದು ಪ್ರಶ್ನೆ ಕೇಳಬೇಕಂತೆ. Shubham, you can go ahead and ask your question.
Yes, sir. Sir, I have only 3 questions, sir. So, first question is that why we are searching more advanced life as an alien? They can also be in the beginning stage. Second question is that the star or a black hole which is present in the center of our Milky Way, Sag-A, is maybe or according to me is a binary pair with the Andromeda galaxies, the black hole present in the in the center of Andromeda Galaxy. And the third question is that galaxy also have their life just like a star. They all it may be possible that galaxy also die with the time. So these are 3 questions, sir.
Okay. You asked me 3 questions, and What was the first one again?
Why do you think aliens are advanced than
Right. I know.
human beings?
I know. I'm deliberately doing this. No, I mean the information that you may have is probably incorrect because as an influence of Hollywood movies, somehow Hollywood has drilled it into our heads that aliens are always going to be an advanced civilization. They are going to come at us with lasers and lightsabers and other things, and they are always going to kill us. And America is always going to save us. So that is their only job to do. But no, when if you look at the data that's come out of the Kepler, space craft, which has found hundreds of extrasolar planets. One thing that you will see common, if you were to look at those planets which are in the habitable zone of a star, until now we have been just able to deduce that the conditions are just right for life to happen, right? There is no talk about advanced civilizations in the scientific community. It is just about finding life, and that is where everybody has drawn the line. Nobody is saying that there will be advanced civilizations or non-advanced civilizations. There could be either. For example, I mean, if you were to look at because that question is kind of different, because let us talk in the terms of light years now. Let us say there is what do you say? When was that dinosaurs that that ruled the earth, right? Yeah, if you say 70 to 85 million years ago, or the Jurassic period, which was about 145 million years ago, okay, right? What would an alien civilization, let us say it is more advanced than us, which is 145 million light years away from us, look at, right? What would they be looking at? Because the light from those dinosaurs, when they were raining, let us say they have a telescope which is powerful enough to even resolve creatures walking on the earth, which is not possible, of course. We are just talking about a thought experiment. If they were to do that, and they will see dinosaurs there, they will think, oh, this is not an advanced civilizations. But the truth is, humans are already there. We are already having large dish antennas and trying to communicate with aliens, and all those poor aliens are seeing our dinosaurs. I mean, that's the whole thing. It's very relative. So we are not searching for advanced life. Only Hollywood is. So no, we are just searching for life. So the second thing about the binary, the paired black holes that you're talking about, probably that is true. I do not have any information regarding that. Third one, what is the third question, please?
Shubham. Did we unmute him? No, he's. I think. What is the third question, Shubham? Unmute yourself. Yeah, Shubham, unmute yourself.
Yes, sir. Sir, my third question is mine. That galaxy also have their life just like star.
Well, the life of a galaxy, I don't know how to quantify it, because the life cycle of a star is different from that of a galaxy. I mean, Madam Rachna, that time, I think she was the one who talked about galactic mergers, right? That is probably how a galaxy can die, if you were to call it that. As we know it, the Andromeda and the Milky Way can merge, and a lot of gravitational interaction that happens, and then things can go kaboom. But I cannot comment precisely on what your question is, but rather if we were to think about it, because any galaxy will have stars of different age groups, right? There'll be really young stars. If you were to look at the Orion Nebula, it's a nursery of stars. There are very, very young stars. Even the Pleiades star cluster that is there, they are very young stars. Or other things. And then there are really old stars like those in the Omega Centauri globular star cluster. Right? Birth and death keeps happening. It's a roundabout thing, and one dies and another takes birth, and things like that. And the hydrogen gas keeps getting recycled in the stellar nurseries. So therefore, if I don't think you can actually say that one day the galaxy will simply switch off. All of them cannot go poof like that, because the distribution of young stars, old stars, everything is different, and probably a scientific study will probably say that when the galaxy is going to near its end or something like that, probably you'll have a chance of the black hole eating up some central part of the galaxy itself, rather than the entire galaxy together going kaboom. So that, I don't think that will happen. If you were to think about it, that's it. Not even from a physics angle, but from a logical point of view.
Thank you, Satya. Amazing session, great session. So let us conclude this with a note. We are heading for a Navratri. Navratri Mugita Bantu, Vijayadashmi Barta Ide. Again, this is followed, with Deepavali coming in. And one request, ಈ ಸಾರಿ ದಯಮಾಡಿ ಯಾರು ಪಟಾಕಿ ಹಾರಿಸಬೇಡಿ. ಪಟಾಕಿ ಹಾರಿಸುವಷ್ಟು ಖುಷಿ ನಮ್ಮ ಸುತ್ತು ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ಇಷ್ಟೊಂದು ಫ್ಲಡ್ ಆಗಿ ಎಸ್ಪೆಷಲಿ ಉತ್ತರ ಕರ್ನಾಟಕದಲ್ಲಿ ಎಷ್ಟೋ ಜನ ನೋವನ್ನು ಅನುಭವಿಸ್ತಾ ಇದ್ದಾರೆ. ನೀವು ಅದು ಏನೇ ಆದ್ರೂ ನೀವು ಪಟಾಕಿಗಳಿಗೆ ಹಣ ತೆಗೆದಿಟ್ಟಿದ್ರೆ ದಯಮಾಡಿ ನಮ್ಮ ಜನಕ್ಕೆ ಸಹಾಯ ಮಾಡಿ. Maybe we can also take an initiative like last time we had gathered funds from various apartment complexes in Bangalore and helped Karnataka. But you can as well do that. So thank you so much. Let us keep learning. ಹಿಂಗೆ ಕಲಿತಾ ಇರೋಣ. ಈ ಹಬ್ಬ ಆದ್ಮೇಲೆ ಮತ್ತೆ ಸೇರೋಣ. Again, thank you for all your excellent feedback. And keep suggesting what are the new topics to be covered in the sessions to come. And also you can suggest some good resource person also. We will organize those sessions. Thank you so much. Happy Vijayadashmi.
Thank you.